Alright, so this video is just going to briefly go over the exponent rules as well as a couple examples. The examples are the ones from the notes we already took, but if you just copied them down or if you really just need a refresher of how we went through them, this is what the video is going to do for you. The first one we kind of talked about was at 0 power. So if I have something, in this case I'm going to call it x, and I have it or I raise it to the 0 power, you have to remember that always equals 1. So if you have like 2 to the 0 power, that's equal to 1. If you have a to the 0 power, that's equal to 1. And I could have something in parentheses like x squared, y cubed, z to the 10th. And if I raise that to the 0 power, like outside of those parentheses, the whole thing just turns to 1. The next thing we kind of talked about was the negative exponent. So if I have something to the negative a, so x to the negative a, I would have to rewrite it and I would have to turn it into a fraction, and I would move that x to the a to the bottom. When you move something with a negative exponent either from the top to the bottom of the fraction or the bottom to the top, it loses that negative sign in the exponent only, which is what we want. Now you could also have something like 1 over x to the negative a, and we would just move it to the top of the fraction, and remember that exponent would now become positive. So if you had something like x to the negative 9, I would need to turn it into a fraction, so it's going to be 1 over, and now it's going to be x to the positive 9. Since it moved to the bottom, it loses its negative sign. You could also have something like 1 over x to the negative 3. That x to the negative 3 is going to move to the top. It's going to lose its negative sign and now just be x to the third. When you're doing these exponent rules and these simplifying exponent problems, you cannot have any negatives in your answer. So if you do, you're going to have to move the base with its exponent that's negative. The next rule we have is what we call our product rule. So if I have something like ab to the x, I need to distribute that exponent into the parentheses, and I'm going to end up with a to the x times b to the x. You can also write them just stuck together, so a to the x, b to the x. If they're stuck together like that, if they use a little dot, if there's parentheses stuck together, that all means multiplication, which goes back to the product. So if you have something like x, y to the 7th, like I said, we just distribute that exponent into the parentheses, and you end up with x to the 7th, y to the 7th. On the other hand, very similar, we have the quotient rule. So if I have a divided by b in parentheses and it's raised to the x, you're still going to distribute that exponent into everything. So in the end, I would have a to the x over b to the x. So for my example here, I'm going to use m over n to the third. I'm going to take that 3 as the exponent and distribute it inside, and I end up with m to the third over n to the third. Now this next rule and the next couple actually are the ones you're going to use the most. You have multiplication, and I need you to remember that multiplication can be represented in different ways. So I could write 2.3, that's 2 times 3. I could use a little x, so 2 times 3. And I could also have 2 parentheses 3. All three of those are different ways to write multiplication, and we do that same with our exponents. So you need to remember, if you see any of those 3 symbols or signs, that you're doing multiplication. So what your multiplication rule says is if I have 2 things with the same base, so in this situation x to the a times x to the b, what you're going to do is you're going to add those exponents, so x to the a plus b. My example here that I'm going to use is 2x squared times 3x to the 4th. So I have a couple different parts here. The first thing I have is my coefficients, 2 and 3. And the second are the x squared and x to the 4th. Now the 2 and the 3 are the coefficients, so technically we treat them like they have the same base. So we're going to multiply those. 2 times 3, that's going to give us 6. And then remember, we're going to take anything with the same base and multiply them together, which means we're going to add their exponents. So I have x squared and x to the 4th. Their bases are both x, so we can combine them further. And remember, all we stated was that we're going to take their exponents and add them. So I'm going to have x to the 2 plus 4, and my final answer is going to look like 6x to the 6th. I can't combine any further, so that's my final answer. Now we did multiplication, so we're also going to have a division rule, and you need to know the symbols, of course, for division as well. So I can have something like 2 divided by 3. It could be written out with a division symbol, but you also need to remember that a fraction is just a division problem. So if you see something written as a fraction as well, it also is telling you to divide. Your rule for division with exponents is if you have 2 things or more with the same base, so x to the a divided by x to the b, instead of adding like we did with multiplication, we're going to do the opposite and we are going to subtract the exponents. So the example I'm going to use here is 12x to the 7th divided by 3x to the 4th. Again, we have 2 parts. I have the coefficients again, so 12 and 3. And then I have my x to the 7th, and it matches with x to the 4th because they're the same base. So in this situation, I'm going to do it in 2 steps. I have 12 divided by 3, which gives me 4. And then I'm going to take x to the 7th divided by x to the 4th. And I told you with our rule, we subtract their exponents. So I'm going to have x to the 7 minus 4. And when I simplify that even further, I end up with 4x to the 3rd. Again, we can't combine this any further. Nothing has the same base, so this would be your final answer. Now, this last rule we're going to cover is called power of a power. And what it looks like is I have something with a base, so just x to the a, and it's raised to an exponent outside the parentheses. So that's why I have my second exponent of b. What you do with these exponents is multiply. So I'm going to have x to the a times b. So the example we're going to use here, in parentheses, I have 2x to the 10th, and I'm going to raise it to the 3rd power. Now, this is just like your product earlier. It has to go to every single thing in parentheses. So I still have 2 parts in this one. I have my coefficient of 2, and then my x to the 10th. That power of 3 doesn't only go to the variables. You have to make sure it also goes to any coefficients in parentheses too. So I now have 2 to the 3rd, and I have x to the 10th, but it's multiplied times that exponent on the outside 3. I can now simplify this further. 2 to the 3rd is the same thing as 2 times 2 times 2, which gives me 8. And now I have x to the 10 times 3, which gives me 30. And again, this does not simplify any further, so we're done here. So these were all of your rules. Now, you do need to know these rules and they become easier as you practice, but if you don't practice, they don't. So we are going to do a couple examples, and if you're needing more help, please make sure you reach out to your teacher. Alright, so the first example I have is written on the screen. I kind of have 2 parts to this. The first one is what's in parentheses, and the second, of course, is what comes after the multiplication sign. Now, I'm going to look at the parentheses first, and when I do, I notice a couple things. We have some negative, a coefficient. We also have a negative exponent, and usually we'd start there. But when I look at this parentheses, there's nothing to combine inside. So we would usually just start doing our rules. But if you notice here, there's this 0 outside of parentheses. And we talked here, when you have the 0 power, if you have anything in parentheses and it's raised to the 0 power, it goes to 1. That same thing happens in this first example. So this whole first parentheses turns into a 1. So I now have 1 times n to the 4th, and all that leaves me with as my final answer is n to the 4th. I can't combine anything else with it, so that would be your final answer on this first example. Now, in this second example, I'm going to look to see if I have anything raised to the 0 power, and I don't. But I do see a set of parentheses here in the front, so I first need to get rid of that parentheses to do anything else. If you notice with the parentheses inside, we can't combine these any further because they don't have the same base. But I do have this exponent on the outside. So that tells me it's going to have to go inside to everything. And when we told you you're doing a power to a power, we multiply the exponents. So I now have negative x to the 2 times 3. I take the squared it already has and multiply it by the 3 on the outside. And that gives me 6. And I have y, I take the 3 it already has and multiply it by the 3 on the outside. So that gives me 9. I didn't do anything with the second part, so I am just going to rewrite it, negative 2x squared y to the third. Now for right now, since we're just getting used to it, I am going to kind of circle the different parts we have. So remember, in the very first part, I have a negative, and if there's nothing there, you have a 1. So I have a coefficient of negative 1. When I look at my second part, I do have a coefficient, and it's negative 2. Now I'm going to circle my x, so I have x to the 6, or box it, sorry. And on the second part, I also have a base of x, and it's x squared, so those go together. And finally, in the first part, I have a base of y, so y to the 9th gets boxed, and it gets boxed with y to the 3rd. Nothing is unboxed or left by itself, so I know what goes with what, and I can continue using my rules. I'm first going to multiply, so negative 1 right here times negative 2 leaves me with a positive 2. I now have x to the 6th times x squared. And we told you when we're multiplying exponents, we are going to add them. So I have x to the 6th plus 2, which leaves me with x to the 8th. And then finally I have y to the 9th times y to the 3rd. So again, we're going to add those exponents, and we end up with y to the 12th. I can't combine these any further, so I leave it as is, and that's my answer. Now this is your example 3, and what you need to know with these exponent rules is there's many different ways to approach it. Your first step may be different than mine, but as long as you get to the same final answer, you're okay, and as long as you're not like doing any illegal math or breaking rules, you're doing fine as well. So I'm going to go ahead and simplify the top part first. I have my coefficient of 2, but there's no other coefficients up there. I have a to the 4th, and there's nothing else with a, but I do have b squared, and it's multiplied by b to the negative 3. So I'm going to combine those together. I didn't do anything with my 2, like I said, or my a, so I'm just going to rewrite them. But I have b squared times b to the negative 3. So we add those exponents, and I have b to the 2 plus negative 3. So 2 plus negative 3 gives me a negative 1. So I end up with b to the negative 1. Now I still have it divided by a cubed b to the 4th. So again, I'm going to box the parts that I have. I have a coefficient out front of 2. There technically is a coefficient in front of the bottom, which is 1, so we'll just keep that there. I have a to the 4th on top, and it goes with a to the 3rd on bottom. And finally on top, I have b to the negative 1, which goes with b to the 4th. And I'm just going to go piece by piece. So I have 2 divided by 1. That leaves me with 2. I now have a to the 4th divided by a to the 3rd. We really haven't done any division yet. But our division rule tells us if we're dividing exponents that have the same base, we subtract them. So I'm going to have a, and it would be 4 minus 3, which just leaves me with 1. And I'm going to do the same thing with the b's. So I have b, and it's going to be negative 1 minus 4. So you have to be super careful with these negatives, these minus signs. Negative 1 minus 4 gives us a negative 5. Now, you first ask yourself, can you combine anything further? And we can't. Nothing has the same base. So usually you would go on. But I told you in the very beginning that you cannot have an answer with negative exponents, and we do. We have b to the negative 5th. So your last step here is to use that negative power rule. I don't do anything with the 2a. It's all positive. We're good to go. Their exponents are positive. But I have to take that b to the negative 5th, and I have to move it to the bottom. And when I do, the negative 5 loses its negative, and it becomes positive 5. So these are all the exponent rules we covered, as well as some examples. Remember, if you're still needing help, you need to make sure to get some from your teacher.